Hey everyone, welcome to part 3 of your Introduction to Inheritance video or lecture. Okay, so whilst we're still in the base class boat, we're going to look at one base class which is the ultimate base class of all types of objects. And this class is called object. Okay, and we're going just to look at examples and try to unpack what this class is. So the object class, what we've used is a method just to explain how we can do what's it called explicit inversion, conversion of all classes, since all classes, what's it called, full-time student, part-time student, even student, event, arguments, whatever, they all inherit from object. So we're going to make an example for that, and object is a built-in C# class. It's part of the system.object library. So we're going to look at an example for that. So we've got a method here that is a string method that is called using object, and we use that method just to build up a string. We've got full-time, and then you just say plus using object, and object over here, over here it requires an object. And now, since we've got an object that is called full and we've got an object that is called part, in both of these we had full over there, we got part over there. So all objects or classes that you create, whether it's full-time, it's part-time, or whether they are base classes of the student class, they all inherit from this object class. So let's just look at what object has, what methods does object have. Okay, sorry, this is just an output from the previous code snippet. Okay, so what does the object class have? What methods does this class have? It has 4 methods. One's called equals, one's called getHashCode, one is called getType, one is called toString, which I think every one of you is familiar with. Excuse me. So what does equals do? The equals method in the object class. What does the equals method do? This method determines whether or not two objects are equal to each other. How does this do that? It uses the getHashCode. Remember, each and every class that you create, it has the hash code. So what does the hash code? It gets the unique code for each object, useful in certain storing of data and managing tasks. So all of these have a hash code. So if, for example, you've got a part-time student class and you've got a full-time student class, this one is going to have a different excuse me, hash code from the other one. Okay, and if in order for you to determine whether or not these are equal, it actually checks the hash code. And then we've got one method that is called getType, which returns the type or object of our class, object, whatever that is. Whether or not it's a string, it's a class, it's a whatever. So the getType does that. And then one that you are most common with, it returns a string that represents an object. So for an example, if you there's quite a lot of strings that you can return string types. This is the actual base method. So there's ones that you normally use when converting your double to a currency or whatever. So this just converts a string. Okay, your two. So all classes that you create inherit from this class, and these 4 methods are public, which means that all classes that inherit from this class, which all classes that you create, are going to have access to all of these methods, to all 4 methods. That is why you are able to just, for an example, in a class, use the toString method. It's because you inherit from this class. Okay. Then now, let us look at one type of a class, which is called the abstract class. So we've now created a new class or a new program with a class that is called abstract student. So let's just look at a definition of what the abstract class is. It says one from which you cannot create concrete objects, but from which you can inherit. What this means is we cannot create an instance of our abstract classes. You cannot say, for an example, abstract student, and you give it a reference type equals new abstract student. You cannot do that. You are not able to do that in an abstract class. Okay, so how do you create an abstract class? You use the keyword abstract. This is the keyword, so you say abstract class, and you can just say student, but I just say abstract student so that you know that this is an abstract class. So this usually contains abstract methods, although methods are not required. Now, what's special about the abstract class is that this contains abstract methods, okay, and you can also have virtual methods. Now, what's the difference between the abstract methods and the virtual methods? Now, one type of a method is that the abstract method, you can only create this in an abstract class. This method is abstract because it does not have any implementation. It actually is a high-level type of a method. Its implementation is normally in the child class, which is the class that derives this class, the abstract student. Sorry. And now the virtual method, it does have implementation. You can use it in the child class just by saying base.method, which is .accommodation. So in this class, we've got a student class, which has a property that is called a name, which has an abstract method that is called study type, which has a virtual string method that is called accommodation, that already has implementation that it says on-campus accommodation. Now, the other notable difference between the two is that the abstract, if a method is declared abstract, then you have to implement this method in the child class that inherits the class that it's in. If a method is declared virtual, you have got an option of implementing this method in the child class. And you have, for both methods, to use the override keyword. What the override keyword does, it actually invokes the methods that you can implement in a class. Okay, so let us just look at the background around the abstract method. So this has no method statements. It's derived. Classes must override this class, like I've said. Okay, so let me just think of what I maybe must have forgotten. And then something that they might have missed is that this class, the abstract method, when you declare it, you just say public or whatever access modifier that you want to use. Abstract, you have to have the abstract keyword and then give it a data type, and then the method name, open close bracket. If you want to have parameters, you can, and then you close with a semicolon, since there's no code that you're going to have inside. The virtual method, it should have some implementation inside it. Okay, on its own, it can be called in a base class. Okay. Now, so you've got the two types of students. Now the base class, sorry, the child class, you've got two types of students, undergrad and you've got a postgrad student. One says I am an, and then you provide the whatever that implementation in terms of your polymorphism, whatever implementation. So here you might have said I'm an undergrad student, and then over here you might say I'm a postgrad student. So this is the same method, but it's got two different implementations. And remember, this method was an abstract method, therefore it must appear in this class, it must be used in this class. And then this one was a virtual method, therefore you had an option of either implementing the method or not. So it's clear that we did not implement that method over there. So that is why you are able to say, yes, this one you've got on-campus residence. Okay. So thank you for that. We've learned about abstract classes and the object um, class, which is a base, an ultimate base for all objects that you create. So we're now going to have our part 4 video of our introduction to inheritance, which is going to be our last video or lecture for your inheritance. Okay, thank you.